Vishveshvaranandamesham Mahavishtum Jwalantam Sarvatomukham Nrsingham Bhisanam Bhadram Murtyum Namamyam.
Well, all of you, welcome to this online class of chemistry. We have discussed the postulates of Bohr model of atom. Now, in this class, we are going to discuss how to calculate the radius of an orbit of in the Bohr model of atom. Bohr has calculated taking the hydrogen as the standard and calculated the radius of the orbits. So now we'll calculation of radius of an orbit. So if you come to this Bohr model of atom, now we have taken that the Bohr has postulated the nucleus is placed at the center, composed of the protons. The nuclear charge is equal to the atomic number. Atomic number is the number of electrons, protons present in the atom of an element. Hence, the nuclear charge is equal to the atomic number equal to number of protons. And the electrons are moving in circular orbit around the nucleus such that the outward centrifugal force is just balanced by the force of electrostatic attraction existing between the nucleus and the electron. So now let us take E be the charge of the electron, m be the mass of the electron, and v is the velocity of electron moving around the nucleus of an atom of atomic number Z. So the nuclear charge will be equal to Ze. So let me write let the charge of electron E of mass m moving with a velocity v around the nucleus of atom of the element of atomic number Z. So these are the assumptions we made. So this is let the charge of the electron is E, which is 1.626 in 10 to the minus 19 coulombs, or 4.803 in 10 to the minus 10 electrostart unit of mass moving with a velocity v around the nucleus of the atom of an element of atomic number Z. So the nuclear charge is Ze, because charge of the electron is equal to charge of the proton. So that number of protons are there, so there will be nuclear charge will be Ze. And as the electron is moving with a velocity v and mass of the electron is m, and r is the radius of the orbit. The r, let the radius of the orbit is r. So since the radius of the orbit is r, so the outward centrifugal force of the electron will be mv square by r. According to the circular motion, the centrifugal force means the force with which the electron has a tendency to go out is called the centrifugal force, and that is equal to mv square by r. Now this force of outward centrifugal force of the electron is just balanced by the force of electrostatic attraction existing between the nucleus and the electron. So what will be the nuclear force? Nuclear force of attraction upon the electron will be how much? Z E square by R square. This we know. Why? By Coulomb's law, the charge of the nucleus is Ze, charge of the electron is E, therefore Ze square by R square will be the force of attraction between the electron and the nucleus. So at every point, this nuclear force of attraction will be equal to the centrifugal force of the electron. Hence, the electron will keep on moving without falling into the nucleus. This is assumption made by Rutherford. The same assumption was accepted by Bohr also. So taking this to now, we will calculate the radius of the orbit. So now, the nuclear force of this outward centrifugal force, the centrifugal force of electron is equal to mv square by r, and the nuclear force of attraction or the force of electrostatic attraction existing between the nucleus and the electron is Ze square by R square. How do I get this Z? Now Ze is the charge of the nucleus, E1 into E2 by d square. The F is equal to always E1 into E2 by d square. So Ze into E by R square. So this is according to Coulomb's law. If E1 is the charge of this, E2 is the charge of these two particles, and R is the distance between them, then the force is equal to the product of the charge Ze into E, Z square by R square according to Coulomb's law. Now, so we say that the force of the centrifugal force of electron is equal to the nuclear force of attraction or the force of electrostatic attraction existing between the nucleus and the electron. So now if we equate these two, therefore mv square by r is equal to Ze square by r square. We got, therefore mv square by r is equal to Ze square by r, or mv square, therefore r square cancels, so mv square will be equal to Ze square by r. So this is, let us put this as the equation 1. This is the equation 1. So here you see, what is our interest? Our interest is to calculate the value of r. Z we know is the atomic number. E we know is 4.803 in 10 to the minus 10 electrostart unit. Mass of the electron is known to us, 9.109 in 10 to the minus 28 grams. So the only quantity which is unknown here is V. If we can express this V in terms of m, R and E. M, R, E, or M, Z, R, all these quantities, then we can solve for R. So if we look to the postulate of Bohr, the last postulate, the angular momentum, what the Bohr has proposed, the angular momentum of an electron is quantized, means fixed. It depends upon the radius of the orbit. So the angular, it is known that angular momentum is what? mv is equal to what? mvr equal to n into h by 2 pi. This is known to us. mvr is the angular momentum. In circular motion, when the mass m is the mass of the particle, v is the velocity of the particle, r is the radius of the orbit, and n is the principal quantum number, h is Planck's constant. So mvr is equal to n into h by 2 pi. So therefore v, from this we can get the value of v. Therefore v, velocity of electron is equal to v will be what? We will get v, keep here, we get here n, h remains by 2 pi mr. So let this be our equation 2. So this is a value we will be using to calculate the velocity of the electron. So mvr is equal to now z square by r, and velocity of the electron is v is equal to nh by 2 pi mr. So let us put this value here. We want to calculate r. Our unknown quantity is v. V is our unknown quantity. This v is our unknown quantity. So in place we will put the value of v from this equation. So substituting the value of v from 2 in 1. So what will happen here? m v square, v is what? n h by 2 pi mr square, mv square will be equal to what? z square by r. mv square is equal to z square by r. So we put the value of v here. What is the value of v? nh 2 pi mr. So when you put the value here, nh 2 pi mr square will be equal to z square by r. So if we take this, so here I am writing the value of v for our use. We will get b is equal to nh 2 pi mr. This is our equation 2, and mv square is equal to z square by r. This is our equation 1. So these are the, we get now substitute value of this v, we got this. Now what we get now? So what will happen? N square h square by 4 pi square m square r square equal to z square by r. Now r square cancels, and here m is there, so m square cancels. So what do you get now? So we get here r will take, so therefore r will be equal to what? If you take the r here, z square will come here, so z n square h square by 4 pi square z e square m. So this is our equation 3. We got the value of r now. So we got an expression for r, radius of orbit. So we know n, the principal quantum number, H, the Planck's constant, pi 22 by 7, 3.1, Z, atomic number, E, charge of the electron, M, the mass of the electron. Now, Bohr, what he did, he calculated. So, if you substitute the value of all these values are known to us, so we can calculate the radius of any orbit. So, what the Bohr did, he calculated for hydrogen atom. So, I am calculating the Bohr's calculation of Bohr, radius of orbit. So, he calculated for hydrogen atom because he first wanted to explain the hydrogen spectrum perfectly, which was a big question to them. So, he put Z is equal to 1 for hydrogen atom. For hydrogen atom, what? Z is equal to 1. Therefore, R equal to N square H square N square H square by 4 pi square E square M. Now, so this is the equation 4 if you take. So now you see all these are constants. So the radius of any orbit, what is this R? Radius of any orbit. Radius of any orbit is equal to R equal to N square H square by 4 pi square E square M. So this is the formula a student has to keep in his mind for calculating the numericals in the exam. Calculate the radius of the fourth orbit of hydrogen atom. So you will put R N equal to 4. Now for N equal to 1 for hydrogen atom, he put N equal to 1. So R1 radius of first orbit will equal to what? R now N is equal to 1. H, we put the value of H here 6.02 6.6266 into 10 to the power minus 27 arc second by pi with 3.1 we put as 3.1 square and E, the value is 4.803 into 10 to the power minus 10 electrostart unit square, and M is mass of the electron is 9.109 in 10 to the power minus 28 grams. When we put this value, we get here R. When putting this value, we get R. First orbit of hydrogen atom, if you calculate, this comes to 0.529 into 10 to the power minus 8 centimeter. 0.529 into 10 to the power minus 8 centimeter. This is the first orbit of that Bohr could calculate. So for putting any value, for when you want to calculate the value of R, radius of any orbit, you can put the value and calculate from this equation. So he got 0.529 10 to the power minus 8 centimeter, or this is 0.529 angstrom unit. Means children, this value, the value of this is a constant 0.529 10 to the power minus 8. This value is 0.529 in 10 to the power minus 8. So you are calculating, so this is called as Bohr's radius. This is called in the honor of Bohr, they call that as Bohr's radius. This you may get in entrance exam. The Bohr's radius is 0.529 angstrom minute, 0.759 angstrom minute, 9.1091 angstrom minute, none of the above. So answer will be 0.529 angstrom unit. So when n equal to, by substituting the value of n equal to 2, 3, 4, etc., the radius of the radius of L cell, M cell, N cell, etc. can be calculated. So in any problem, you may get an exam in the can be calculated. If you can put the value of n equal to 2, now if you put n equal to you want to calculate second cell, so you will put n equal to 2, so 0.529 into 4. So now let's do this here. So suppose the value of the radius of second orbit, radius of second orbit, that is L cell. L cell will be how much? N equal to 2. N equal to 2. Therefore, what will be the value of it? So R2 will be equal to 0.529 n square angstrom minute, that is 0.529 into 4. So you can put this 3663, we get 2.1. So here 381, 2.116 angstrom unit. So this is the value of radius of second orbit. If you want to third orbit, you will get n equal to 3. So we can calculate. So this is the way Bohr could calculate for the radius of orbit by using his postulates from the Bohr model of atom. This is a great adventure of Bohr, because prior to that, just a model was given by Rutherford. The nucleus is the center, composed of the protons, electrons are moving in circular orbit. He has taken everything, but he applied Planck's quantum theory and he used this value and got it. Now after this one can also calculate what is the distance between first cell and second cell, suppose. So a question in your entrance exam, a question may come that what is the distance between the first cell and second cell of the hydrogen atom. Means first cell, this is the nucleus, that is equal to 1, and this is the first cell and this is the second cell. He is asking. So what is this distance may be a question to you. So that will be what? This is R1, this is R1 and this is R2. So this R1 is N1, N2 is R2. So it will be what? So the distance between the two, if they ask the distance D between the two, if they ask, what will this? 0.529 into 2 square minus 1 square. Okay, second radius will be 0.529, 2 square. First radius is 0.529, 1 square. So 4 minus 1, 3. So that distance will be 0.529 into 3 angstrom unit. Our question may come to you in your entrance exam. What is the distance the electron had jump from when it jumps from first orbit to second orbit? So he has to jump this distance 0.529 into 3 angstrom unit. So now from this we can calculate the velocity of electron. He could calculate the velocity of the electron moving in the first cell of hydrogen atom. So what is the equation for velocity? V is equal to, so now we will calculate the velocity of electron is V of hydrogen atom in the first cell. He calculated. So what is V? Now V will be equal to what? N H 2 pi m r. This. So all these are constants. H is a constant, pi is a constant, m is constant, r is changing. So we will put the value of r only. We will put the value of r. The first orbit is 0.529. So if you put the value of n is equal to 1. So if you put the value, now the first velocity of the electron in the first orbit will be what? N equal to 1. Now h is 6.626 in 10 to the power minus 27 arc second by 2 into 3.1 into m is 9.2 109 in 10 to the power minus 28 grams into the R is 0.529 in 10 to the power minus 8 centimeter. So if you put the value, the velocity comes to as V moving in the electron comes to 2 if we solve this, this comes to 2.188 in 10 to the power 8 meters per second. So this is the velocity of electron moving in the first orbit of hydrogen atom. So all these values are constants. You see, the only value will be changing what? This value will be changing. All these other values are constant. So you can calculate for the second orbit, velocity of electron, third orbit. In your entrance exam, generally what happens? These are the questions come. Generally people, they get confused. The students get confused. So most often they try to remember. No question of remembering. You remember that R, the radius of orbit, is 0.529 n square angstrom minute. 0.529 n square into 10 to the power minus 8 centimeter. You remember this? So then everything you can calculate by putting n equal to 1, 2, 3. You can calculate the radius of different orbits and this. Now we can then what the Bohr did, he could calculate the energy of electron. So just I am giving you an introduction of calculation of energy of electron. So next class I will calculate the energy of the electron. So what we are going, if he calculated also the energy of electron for a formula he derived, and from that he could calculate the energy of the electron moving in the first orbit. So what is this? So the electron is moving. So the electron will have now so the total energy of the electron will be what? Sum of the potential energy of the electron due to its position and the kinetic energy of the electron. Potential energy of the electron and kinetic energy of the electron. If you take the sum total of these two, then total energy of the electron. So next class we will calculate the energy of the electron. So if you have not subscribed our channel, you please subscribe the channel Chemistry RN Panda, and so that all the notifications that will go to you when we are uploading this. So this is a very important topic in atomic structure. Next class we will discuss about energy of electron and Rydberg constant and series combination principle. Thank you so much.